Hello, good morning.
Good morning, sir.
Let's wait for the other student to join. So, have you completed the homework?
Yes, sir.
Then why you haven't said me yet?
Sir,
Then why you haven't shared with me?
the work, sir.
Sorry?
You mean the homework, sir?
Yeah, yeah.
Uh, I thought not. I don't know, sir, to share.
Look, you can make a PDF and send me personally, no problem.
Okay, sir. After the class, I'll send you.
Okay. So till yesterday, till the last class, we have covered this question, sugar cubes one, and okay. Why is he not joining yet?
Sir, should I send you personally or on the group, sir?
You can send me personally, no problem.
Okay, sir.
Good morning, Renal.
Good morning, sir.
Yeah. Have you completed the homework?
Yes, sir. But the FRQs you sent, I think two of the parts, I think I couldn't see the questions.
You are not able to understand the questions? Or
Questions
what?
दिखाई नहीं दिया. Like they're not.
You can't see the questions, you mean?
Yeah.
Oh, is it? But
The
why?
second and third, calculate the number of grams in 0.03 mole of each compound listed in question A, C, D, B, A, B, C, D, A, B, C, D. Third, second and third, the compound is not mentioned.
They're saying na listed in question one itself.
Oh shit. I didn't see that. Okay.
First of all, this is your bad habit. You guys are not reading the question properly. Improve this habit, okay? And turn on your videos quickly. And let's begin with the today's class.
Yes,
So,
sir.
in the last class, we have discussed that atomic mass is nothing but relative atomic mass in U units. Remember? We have done one question also regarding that.
Yes,
And
sir.
today I am just giving you a quick overview of molar mass. What do we mean by molar mass? Molar mass is basically mass of 1 mole of atoms. Any atoms you take. Mass of 1 mole of atoms. Okay. What do you mean by mass of 1 mole of atoms? Let's say I am taking one example for sodium. Okay. So can you guys tell me what is the mass of one sodium atom? Can you tell me what is the mass of one sodium atom? Just one sodium atom?
23 grams.
Grams.
No, AMU.
Yes, 23 U. Arey, why you guys are so scared while turning on your videos? What I will do with you? No, it's fine. So mass of one sodium atom is 23 U, right? And then if I want to find out mass of one mole of sodium atoms, then what I have to do? I have to multiply this value with 6.022 into 10 to the power 23, isn't it? I mean, if in one mole these many particles are there, so mass of these many sodium atoms must be required, which is 23 U into 6.022 into 10 to the power 23. Do you agree with me?
Yes, sir.
Yes. Let us convert these things from U to grams. How will you convert it? From U to grams. By simply multiplying with
1.66 into
1.66 into 10 to the power minus 24. Now it is in grams. Similarly, here also I will do the same thing. I will multiply it with 1.66 into 10 to the power minus 24 to convert it into grams. If you remember that these are the reciprocals of each other, I explained you. I told you you can calculate this value. These are the reciprocals of each other, right? So that means, sir, it is basically you are basically getting 23 grams as the answer. Yes, yes, molar mass is represented in grams, and molar mass is nothing but RAM, relative atomic mass only, but in gram units. In gram units. Done. This is the net conclusion we should know. Molar mass is nothing but relative atomic mass in gram units. If this is clear, then you guys might be thinking that, sir, when we are denoting atomic mass, we denote it using gram per mole symbol also. But I am telling you to denote it in U units. Sir, why gram per mole we are not using? You can use that as well. But sir, then how that gram per mole unit is coming from? From where that unit gram per mole is coming from? So now, because you know that mass of one mole of sodium atoms is 23 grams, isn't it? This we know that mass of one mole of sodium atoms or mass of these many particles of sodium atoms is 23 grams. Can I write in this form also? That mass of one mole sodium atoms is 23 grams. So if I want to find out now from here, what will be the mass of one sodium atom? From here itself, I am trying to find out what will be the mass of one sodium atom. How will I do that? Sir, you simply divide it by a mole. It will be like 23 gram divided by a mole, isn't it? 23 gram on the top, and because I am going from 1 mole to 1 atom, I have to divide it by 1 mole. Yes, I have divided by 1 mole, so it is representing as 23 gram mole inverse. I hope it is 100% clear. So sir, this you have calculated what? This I have calculated the mass of just one atom. And you remember that mass of one atom is nothing but atomic mass. So that atomic mass is represented in U units as well as you can represent atomic mass in gram per mole units. That means U and gram per mole both are exactly equal. Very, very, very important. Many students have the confusion. Sir, what is U? What is gram per mole? Both are same. I hope it is clear. 100%, right? Both of you?
Yes, sir.
Okay. Fine then. Then comes another interesting thing to be answered. Let us say I am having any chemical compound represented as AXBY. AXBY. This is any molecule, any compound, I don't care what it is. Any molecule, any compound. Okay. If I ask you how many total number of atoms are there, how many total number of atoms are there in this? If you have many molecules of this I have been taken. Multiple molecules, you assume. I am not giving you any number. Think many molecules I have for this AXBY compound. Okay. So how many total number of atoms are present in AXBY if you have many molecules of AXBY? Sir, one molecule of AXBY if you take, then it will be having X amount of A atoms and Y amount of B atoms. Do you agree with me? In just
yes,
one
sir.
molecule. X amount of A atoms will be there, Y amount of B atoms will be there. But sir, now you are not having one molecule, you will be having many number of molecules. So can I say it will be X amount of AXBY molecules plus Y amount of AXBY molecules, total number of molecules of AXBY. Or I can also write it as X plus Y into number of molecules of AXBY. Do you agree with me? Will this quantity be
Sir,
giving you
total
total?
number of molecules of AXBY will represent it by N only.
You can
For
represent it
N,
by N only.
it
I
will
am
be
not
easier to
representing.
understand, no? That's why.
Yes, it is
Because,
actually, but
but if you're taking AXBY, why is molecule coming here? Then I'll get confused.
I understand that point. Don't worry. I understand that point that what you want to say. But for now, you please write it in this way because I want to explain further things.
Okay.
Okay. So, but is it clear that the total number of atoms will be coming from A atoms as well, which is the X amount, and the B atoms as well, which is the Y amount, and
Yes,
then
sir.
multiply them with the total number of AXBY molecules, whatever you have. Okay. This is the total number of atoms I will be getting. Fine
Yes,
then.
sir.
Let us look on to the only total number of A atoms. Total number of A atoms will be how much? If I ask you. Total number of A atoms. Just A atoms I want. So how will you find out? Sir, it will be nothing but total number of A atoms is how much? Sir, A atoms is X. Like in one molecule, we have X A atoms. So in many molecules of AXBY, I will be having X into number of molecules of AXBY. Can I write like this? I don't think so. There is any problem writing this, right? And I can also write total number of B atoms will be how much? Total number of B atoms. It will be Y into number of molecules of AXBY. I hope this is also clear, right? 100% sure hope this is fine.
Yes, sir. Yes, sir.
Yes, sir.
Okay, cool then. And let's move to further thing. Let us now say that I am having one element called X. So if X is there, then what is Z represents, what is A represents? You know this, right? Z represents the proton number, A represents the mass number, or you can find out the neutron number as well from there. And if it is a neutral atom, in a neutral atom, my number of protons, which is equal to Z, is also equal to number of electrons, can I say? Because there is no charge on it. It's a neutral atom, so protons and electrons must be in the same number. Do you agree? If you are agreeing with this, then can you tell me total number of electrons in AXBY? How much it will be? Just try to find it out. I am repeating, I am not having just one molecule of AXBY. I am having, let's say, n molecules of AXBY or many molecules of AXBY. So how many total number of electrons will be present in AXBY as a whole? In many molecules of AXBY. Can you tell? Think a little, think. Sir, we
Sir,
have two
X
atoms.
into number of electrons in A plus Y
Yeah.
into number of electrons in B.
Into
Into
as a whole.
total, yeah, into total number of molecules of AX plus BY.
Yeah. What about you, Ram?
Z of X plus Y.
Z of Z of X plus Y. Okay. And then you mean to say this, right? That you take Z, sir, and Z of X plus Z of Y, isn't it?
Yes, sir.
Okay. Then these Z's are different, but right? These Z's are different. Z you ha
Yes, sir.
then you have to write it in this way that you take sir zx of x plus zy of y, isn't it?
Yes, sir.
Yeah, okay. Then multiply it with the number of total number of electrons, sorry, total number of molecules of AXBY. Yes, this is the correct way to find out the number of electrons, or the other way also the minister told that sir it can be like the represented like this also, that x into number of electrons in A plus Y into number of electrons in B. See, no one is asking you formula, right? It is for us to understand. In AP, no one asked you anything. Into number of molecules in AXBY, and it's done. This is the way. Both are the same things. You can use anything. Okay. Then, if you understood this part as well, a quick question to you guys from my side is calculate the number of electrons in 9.8 grams of H2SO4. Can you do it? Fast, fast, fast.
5 Na, sir.
5 into Na. Okay, one answer is correct.
Same, sir.
Okay, good then. Answer is 5 Na. If you get up to this answer, then I hope you understood this concept as a whole. Then one more question from my side to you guys is this. Let's say I'm having hemoglobin which contains 0.34% of iron by mass. The number of iron atoms in 3.3 gram of hemoglobin is. Atomic mass of iron is given to you, AR. Fe का दे रखा है 56. You need to tell me the final answer for this question then. Quick, quick, quick. You want to find out the number of iron atoms in
0.02 Na.
0.02 Na. No, I don't think so. This is the correct answer. Any other answers? Or you are a little bit confused in this question? What happens? Okay, let's do it together then. If someone is doing, please continue. I am also doing here. So what they are saying if you have one hemoglobin, yeah, you got the answer, Ram?
No, sir.
No. Okay. See, let us assume that we have just one hemoglobin atom, just one. So in one hemoglobin atom, or I can say, let's say you are having 1 gram of hemoglobin atom. So how many, what gram of iron it will be having? It will be containing.
0.34.
Yes, in 1 gram it will be just Sorry.
0.34
How
grams.
you can say in 1 gram it will be 0.34?
सर अभी 100 को लेते तो 34% has iron, 34% of it has iron, so 0.34 grams has iron now.
No, wrong. Wrong. If we let's assume that if we have 100 grams of hemoglobin, then you can say we are having 0.34 grams of iron in it. Don't you agree with
But
me?
34% of 1 is 0.34 only now.
34. Are you given with the 34%?
Yeah.
We are given with the 0.34%.
Oh, okay.
You are getting confused, I hope. See, if
Sir,
you
can
take
you show
100.
the question once? Question एक बार
Yeah,
show.
yeah, sure.
Wow. Okay, sir.
Now
Okay.
it now it's fine, right? Yeah. See now, 100 gram of hemoglobin if you take, then it might contain 0.34 gram of iron. Yeah. That means, sir, if you take
No,
100%, then
sir,
it will
sir.
be 100.
Yes, sir. Yes, sir. Correct.
Okay.
Yeah.
Okay then. So now I am not having 100 grams. I am having how many grams of hemoglobin with me? Just 3.3 grams, sir. Just 3.3 gram I am having. So what I should do? Sir, you know the basic math, right? 3.3 into 0.34 divided by 100 you have to do. Do you agree with me? Because it's a 0.34% of any amount of hemoglobin you take. So I'm doing that only. 3.3 grams. This is the amount of hemoglobin I took into 0.34, which is the percentage, and divided by 100 because it's in a percent. I hope it's clear, right?
Yes, sir.
The Ram, clear?
Yes, sir.
Okay. So this is the thing, first of all, which we need to calculate that in actual
2 into
practice.
10 to the power of minus 4.
Sorry,
It's 2 into 10 to the power of minus 4.
this value you are saying?
Yeah.
I'm not concerned about this. Why? Because I want to further solve it. See, this is what? This is weight of iron is given to me as this in 3.3 grams of hemoglobin, let's say, right? This is what I have calculated here. Yes, exactly. I have no need to calculate in this step itself. Let's do it later. Why? Because I don't want to calculate the weight. I want to calculate the number of iron atoms in this sample. So how will you calculate? See, you are given with the mass of something. You want to reach to the number of atoms of something. How will you go? Which path will you follow? The Y map? Mass is given. Convert them to moles. Convert moles back to the number of atoms, isn't it? I think it's easy, right? So to
Yes, sir.
find out, okay, number of moles of iron atoms in this quantity is how much? It is 3.3 into 0.34 divided by 100. And what else? Divided by the molar mass, the molecular mass basically, divided by 56, right? This is the number of moles I'll be getting. And then, sir, if you want to find out the number of atoms of iron, it will be like 3.3 into 0.34 divided by 100 into 56 into 6.022 into 10 to the power 23. You have to solve this value, you'll be getting the answer. Just do it. Just do it using your calculators. In the final, don't round it off at any step. Don't round it off. Whatever the value you're getting, just keep multiplying, keep dividing.
3 into 10 to the power of 6 Na.
3 into 10 to the power of 6 Na. You are saying. How? I don't think so. This is the correct answer. 3.3. Let me do it also. 3.3
Sir,
into 0.
what type of calculator should can we use in the exam?
It will be on-screen calculators which will be given to you.
We should not get any calculator physically.
No. I am getting some different answers after calculation of this. Please calculate it carefully. Do it once more. And whatever the value you are getting, please let me know.
Zero point 0.12 into 10 to the power of 21.
So how can you represent it in more better form? 1.2 into 10 power 20?
Yes, sir.
Yeah. Ram.
12 into 10 to the power of 21 we can also 22.
It's usually written in the form of decimals if decimals are there.
Okay,
Okay.
sir. Okay. Sir, what should you, last class, what did you tell to know apart from that?
Significant figures.
Significant. Okay, sir. I'll learn that.
Didn't got the answer, Ram?
No, sir, doing.
Okay, do it. You're using calculator, right? Or you are doing it by hand?
Calculator, sir. I did a error, sir, so it took time.
Okay, okay. Now you got it.
Sir,
What is the answer?
actually, the calculator is not working, sir, in this one. So,
Okay, how to use a calculator? Let's discuss that. Don't even solve. Don't even put the 10 to the power things in the calculator. I've never put. Okay,
okay.
so just from the calculator, what you want to find out this value. This multiplied with this or divide with this. Nothing else. Okay, don't put any 10 to the power digits on the calculator. It will be a blunder for us to do it at this
Okay.
stage if you are that big. Okay, so just we know that, so it will be nothing but 3.3 into 0.34 into 6.022 divided by 56 into 10 to the power of 21. Now you to solve this value, whatever you are getting, just bring them into the correct number of significant figures and the answer is done. Okay, so the final answer I am getting is 1.21 into 10 to the power of 20. I hope this is clear. You can do it at your homes. If you are unable to find out the answer, let me know in the next class if you are still having some doubt in this question. I hope the meaning of the question is clear to you.
Yes,
I'm not
sir.
discussing. Okay, fine then. Let's move further. Now the next topic is finally called the empirical and the molecular formula. Empirical and molecular formula. So, okay, let me say that I am writing something like this, C2H6. From your 10th class knowledge, you can tell me, sir, this is ethane. Yeah, isn't it? Sir, it is ethane. Okay, I said, okay, fine. This is ethane. What is this ethane? What you have written over here? What is this called? This is called the molecular formula of any compound. Molecular formula. This is a molecular formula. I said, okay, fine, no issue. Then, can you make it even more in a simpler form? Can you have a simplest ratio of this? If yes, then what will be the new formula which you'll be getting after taking the simplest ratio here?
CH3
CH3. Okay, what you have done to make the simplest ratio? What you have done? Divided with something, multiplied with something, or what?
divided by 2.
Divided by 2. Okay, remember this thing. Acha, now what is this then? Whatever the simplest ratio you have calculated, whatever the simplest ratio you have calculated, this is called your empirical formula. Empirical formula. I hope it is clear. Then, let me ask you another question. Let us say I am having empirical formula as this. Okay. And now if I multiply it with 2, then I'll be getting my molecular formula back. Not multiplying with 2 means, no, I'm not multiplying as a 2 as a number here. I'm multiplying here, this sides. Okay. Yeah. So that means, sir, it is nothing but you want to do empirical formula into some n value. This is I'm saying as n value. so that I can get a molecular formula. Isn't it? Yes, exactly. Now, in the question, what they will give you? In the question, they will give you the molecular formula weight. They will give you the weight of this thing. They will give you some data to find out the empirical formula yourself. And they want you, in the final question, they want you to find out the molecular formula only. Molecular formula weight will be given. Some data will be given, using that you can find out the empirical formula. And then you need to find out the molecular formula. So to find the molecular formula, what I require? Sir, you require empirical formula into N. Sir, how can we find out this N value? See, I just told you that molecular formula weight will be given to you, isn't it? Molecular formula weight. Can you tell me the weight for this? This will be given to you. The weight will be given to you. The formula will not be told you. Like, they will not tell you the formula. You want to find out the formula. But they will give you the weight of this sample. Can you tell me the weight of this sample quickly? The molecular weight?
30.
Coming out to be 30?
Yes.
Yes, coming out to be 30. Okay, so this will be given to me. And now if I want to find out N, what shall I do? Sir, what you do, you take molecular formula weight, because this will be given in the question, and divide it by the empirical formula weight, because empirical formula we are calculating ourselves. So we know what is the formula. We can calculate the weight of that formula and divide them. Will you be getting the N again? Yes, sir. We will be getting the N again. Put this N value here and molecular formula is done. You got the molecular formula. But the main thing here is to find the empirical formula from the given data. What type of data will be given to us, sir? I will tell you. I will give you a question regarding that question. Let us do it. Let us say a compound. This is the most, you can say, trickiest question they can ask. This is the most trickiest question they can ask. A compound has 42.1% carbon, 6.4% hydrogen, and remainder remainder is oxygen. They are saying that its molecular weight is 342. Then the molecular formula is then the molecular formula is what it will be. Now see, you are given with some data in terms of some percentage. Hello guys, can you hear me?
Yes, sir.
Your meeting was also down, or it was just mine?
Just you, sir.
Oh, sorry, sorry. Maybe some internet fault from my side. Just a second. Let me join from the iPad. Can you see the screen?
Yes,
Yeah.
sir.
Okay, fine then. Let's begin with the this thing. I was saying to you guys that they might give you either the percentages or whatever the remainder percentage we can calculate from here, right? Or they might can give you grams as well. It doesn't matter to us, whatever they are giving to use. Okay? We have to use the same trick to do this type of questions. Sir, what we have to do? You have to form a table. You have to form a table. Sir, what kind of table? So just we need to understand once how to form a table and we are good to go. So write element over here. Then write the percentages or gram, whatever you are given with. Okay. Then percentage or gram, whatever is given to you, divided by the atomic weight of it. Atomic weight of that element. You will be getting some value here. Then you have to take a simple ratio of it. Simple ratio of the value. And it's done for us. Simple ratio of value. Let us do it. Let us do it quickly. Can we? Can we do it together? What is the element? Okay, turn on your videos, please. Let us do it quickly. So I am having carbon as what percentage? I am having carbon as 42.1%. Do you agree with me? Then hydrogen. Hydrogen is how much, sir? It is 6.4%. Or don't write the percentage. And oxygen is whatever the remaining value you are getting. Right?
Yes, sir.
What is the remaining value? Subtract it.
48.5 is the total.
48.5.
52
Okay.
point, I think it's
Acha, this is
51.5.
48.5 you are saying. So it will be
51.5.
51.5. I said okay, fine. Then I have to divide each of them by their atomic weights. So that means, sir, 42.1 divided by atomic weight of carbon, which is 12. Then 6.4 divided by 1. Then 51.5 divided by 16. Solve this value quickly. What you are getting? Quick, quick, quick. And turn on your videos. I will not repeat again and again. This will waste the class time. Solve this values quickly.
First one is 3.508.
3.508. At least up to 3 decimal places report me the answer for now.
Third one is 319.062. No, 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 third one. Yeah.
No, I
319.
think there is some flaw. 3.218. Okay, fine. Ram, same values you're getting?
Yes, sir.
Cool then. Fine. Now you have to take the simple ratio of these values. Sir, how to take the simple ratios? Whatever the three values you have, which is the smallest value out of these three? So the third value is the smallest. Divide everything with that third value. Divide all of them with that the third smallest value here. Okay, let us do it quickly. So sir, it will be like, you mean to say 3.508 divided by 3.218, then 6.4 divided by 3.218, then 3.218 divided by 3.218, isn't it? Yes. What is the answers you are getting here again? Tell me quickly. Yeah. Values, quick.
First one is 1.090.
1.09. Okay.
Second one is 1.98.
1 point.
98.
The next number after 8.
8.
1.988 means 1.99 I can write.
Yeah, sir.
Okay. Then 3.218 by 3.218 is 1. Okay. Fine. Sir, 1.99 I can approximately treat it as 2, isn't it? Because it's a very close
Yes,
value.
sir.
Very, very close value. But 1.09 you cannot treat as 1. No, it is a far value. See, I can only approximate if I am given with 0.99 or 0.01. Like this can be approximated to 0, this can be approximated to 1. This approximation is valid approximation, but you cannot do 1.09 to 1. No, it is a big blunder people do. No, it's not right. Are you getting this point, both of you? Small value, very, very small change you can
Yes, sir.
approximate, but not a even bigger change than 0.01. 0. More than 0.01 bigger change you cannot approximate. Very
Okay,
small
sir.
change you can approximate. This, which is this. Acha, okay, sir. Then, and whenever we write a empirical formula, we need everything in the form of natural number. Sir, did we got the natural number till now? No, sir. This is a decimal point. This is not a natural number. We have to convert it into natural numbers. So the fifth column will be the conversion to natural numbers. So how to convert them to natural numbers now? How to proceed that? Tell me quickly. How to find out the natural number out of these three? Like all must be in
Sir,
natural
divide
numbers
by
now.
greatest number which is there.
Okay, if you divide by 2, otherwise everything will be in fractions again.
Yeah. Or multiply that number, I mean every number, so that 1.09 becomes whole number.
Yes. Multiply with this any value, all the values with some digit, using that with which this all the digits become natural. Sir, then we have to multiply them with a natural number itself. Yes, obviously, I can't multiply with any fractions. If you multiply this value with some fraction, let's say 0.2, it will become 0.4, again a fraction. You are disturbing a already natural number. You are moving it to a decimal point number, which is not allowed. That means, sir, I have to multiply with any natural numbers over here. So which
100.
natural number shall I take?
100.
100. Hey, the
Yes.
smallest number. The
50.
smallest number we require. The smallest natural number you have to multiply with. Which is the smallest natural number I can take? Sir, can I take 2?
But it will be
No,
again.
we
Yes,
cannot
sir.
take 2. Can we take 3? No. Again, a decimal point number you will be getting. 4? No. 5? No. 6, 7, 8? No. 9? No. 10? 10 will give you 10.9. Again, you can't balance it to 11. Sir, 11? Can you take 11?
Sir, we can take 10 now, sir. Round off.
10 point, see if you multiply it with 10, 1.09 multiply with 10, it will be what? 10.9? So then 10.9 I can't balance, I can't approximate. This is a very huge thing which you are trying to approximate. See, I told you that only 0.01 approximation is allowed. Not even 0.02 approximation is also not allowed. And you are saying to me that, sir, 10.9 we can approximate to 11. This is then you are approximating up to the digits of 0.1. This is even not allowed. It's a very big number we are approximating. Not possible.
Yes, sir.
Then try to multiply it with 11. Just try everything multiplying with 11. What you are getting the answers? I think 1.09 multiplied with 11 will give you 11.99 if I am not wrong. And this will give you 22. This will give you 11 again. Check it. Yes. Now 11.99 is such a change, such a value which you can approximate to 12. Do you agree with me? It's a basically hit and trial type of thing which you have to do here,
Yes,
and
sir.
which is asked rarely in the exams. See, I will tell you, your final answers, your natural number things will be done up to this step. We don't have to solve for the natural number of by multiplying it with some other numbers every time. No, it's not required. Just for a few questions, few rare questions, we have to do this extra step by multiplying them with the natural number so that everything becomes natural. Okay, so this number in this case is coming out to be 11. Okay, no issue. This is basically a hit and try which you have to follow. Then sir, what is the final ratio I am getting? I am getting 12, I am getting 22, I am getting 11. This is for carbon, this is for hydrogen, this is for oxygen. So this will be your empirical formula as well. C12, H22, O11. Fine. But what they demanded, did they demand you empirical formula? No, sir, they have demanded from us the molecular formula. How to find out the molecular formula? Sir, multiply the empirical formula with the n value. Sir, where is the n value? Currently, we don't have the n value. So find that out. You are given with the molecular formula weight. You're given with the molecular weight. And you can find out the empirical weight yourself because now you have the empirical formula. So calculate the weight of this quickly and try to find out the n value. N value is nothing but molecular weight divided by empirical weight. So molecular weight is given to you as 342. And what is the weight of this coming out to be? Check it out quickly. I guess it is also coming out to be 342 itself because 12
Yes,
12s
sir.
are 1,
Yes.
12 12s are 144 plus 22, 166, I
This is
guess.
198 plus 144. It's 342 only.
Yeah. Okay. So 342. So sir, that means the n value is coming out to be 1. So if it means, sir, empirical formula, whatever you are having, you have to multiply it with 1 to get the molecular formula, which will be the same as the empirical formula only. Yes. So this is only your empirical formula as well and molecular formula as well. So molecular formula is also this. I hope it is 100% clear now. Yeah. This type of questions will
Sir.
you be able to do?
Yes, sir.
Okay.
Yes, sir.
You will be getting more questions in the homework now. I will be giving, right now we are doing 2 3 more questions. First is this one. Uh, let's say an oxide, an oxide of iodine, given the molecular weight of iodine, it is given to you, okay, which is 127 gram per mole. Contains, this is for iodine, contains 25.4 gram of iodine and 8 grams of oxygen. Okay, they are asking you its formula could be. What is the formula? Its formula could be, you are given with the 4 options as well. First option is I2O3, second option is given to as I2O5, the third option is I2O, and the fourth option is I2O7. Use the same method, use the exactly same method and tell me the answer. Form a table, element, the percentage or whatever the grams is given to you, percentage, yeah, or grams divided by their atomic weights, and then finally the simplest ratio. Quick. It's not a difficult question. It's an easy question.
Is it D? I207.
I don't think so. What you have done? Let us quickly try it. Element you have written over here. Grams you have written over
Yes.
here. Gram by atomic weight you might be doing here. And then finally simplest ratio, right? Okay, let us try it. If it is coming out to be 807, I'll be more than happy than you. Let us see. Like iodine you are writing here, oxygen you are writing here. What is the mass of grams of iodine given to you? 25.4, oxygen is 8. So 25.4 divided by 127
Yes, sir.
and here 8 by 16, right? It is coming out to be what? 0 0.5 and it is coming out to be what? Have you solved this?
0.2
0.2.
into
Okay.
5 into 5 into 10
So what will you do? With what factor you will multiply they will get so that they can get. So first of all,
into 10 into
whenever
10.
no.
No.
Arey yaar. See, don't forget one thing that when we get this values, these values after the percentage by atomic weight,
Okay,
you have
okay.
to think about the smallest value out of this and divide it by that.
Okay. Yes, sir.
This is the first step we have to do here. So that means 0.2 divided by 0.2 and 0.5 also divided by 0.2. So here how much I am getting?
1, 1.
Then I am getting 1. And here you will how much you are getting? I guess 2.5.
2.5. Yes.
Now this is not a natural number again, but this is very very easy to convert it into natural number by just multiply it with 2. So
2
2
and
and
5.
5. So I
Yes,
am
sir.
getting I205 as the correct answer, not I207.
But, sir,
Hmm.
if we neglect this method and it says the compound is 127 grams.
Not compound. The weight of the iodine only is given to you.
Okay, okay, okay. The weight of the compound is not given.
No, the weight of the compound is not given to us.
Okay, okay, sir.
Okay, so I205 is the correct answer. Ram, what about you?
Yes, sir.
Got
Got it.
it?
Got it.
Okay, one more last question regarding this topic you take, which is saying to us, okay, something like this. An oxide of sulfur contains 50% of sulfur in it. Its empirical formula is. Its empirical formula is. So this, there is no need to use your lot of brain. Think a little bit and you will be able to do it. They are saying that there is an oxide of sulfur which has 50% amount of sulfur in it. Rest is oxygen. Yes?
SO2,
Yes, obviously SO2. Sir, if we take SO2, let us say, Acha, what are the possible oxides of sulfur? Sir, either it is SO2
SO2 or
or
SO3.
SO3. Yes, two oxides are possible, or SO2 or SO3, right? So then SO2 you see, sir, it is S is having the mass of 32 and two O's combined together also has the mass of 32. That means this is also 50%, this is also 50%. Done. Whereas in the case of SO3, if you go, so this is having a mass of 32, this combinedly has a mass of 48. So the ratio will be different then. Do you agree with me?
Yes, sir.
Yeah. So this is how you have to solve it. The ratio will be 2 is to 3 here. 2 is to 3 means you take 2 by 3 of 100 and you can try, sorry, 2 by 5 of 100 and 3 by 5 of 100, you will get the answer, how much ratio, in what percentage they are present. Okay, fine.
Yes, sir.
Okay, cool then. So then comes another part called the percentage composition by weight or by mass. Percentage composition by mass. A very, very easy topic for us to understand percentage composition by mass. What it says? It says that let's say I am having something like NaNO3. No, wait. Let me say something else. What we can take? Some good examples. Yeah, this we can take maybe. N2O5 as an oxide. N2O5. Let us take that. Now they're asking you what is the percentage of N by mass in N2O5? Can you find it out? It's very easy. It's very easy to do that. How, sir? Nothing you have to do. See, listen carefully. Nothing you have to do. How much N you have? How much nitrogens you have?
2.
2. What is the mass of one nitrogen?
14.
14. Divided by the total mass. What is the total mass of N2O5? Sir, it will be 28 plus 5 into 16. How much? 80.
80.
So 28 plus 80 is 108. So this is, you are dividing mass by mass. So it will give you percentage by mass of any substance. You want to find for N, put the mass on the numerator for the N and divide by the total mass. You will be getting 28 by 108, whatever the answer you are getting. It's in percentage. And multiply it with 100 also, sorry. Because you want to find out the percentage, right? So multiply it with 100 to find the final percentage. You will get the answer in percentages. Similarly, if you want to find the percentage of oxygen by mass in again N2O5, so either what you can do is from 100 you can subtract this x value. Yes, this is the first method you can do, or simply what you can do is put the mass of oxygen in the numerator. What is the mass of oxygen? 80. Divide by 108, multiply it with 100, you'll be getting percentage again. It's totally up to you how you have to do it. It's fine? Clear?
Yes, sir. Clear.
Yes, sir.
Okay, good then. So this is the way to find out the percentage composition as well. I don't think so there is any problem. And now let us move to a very, 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 very important concept called mass spectra. Mass spectra. Oh, sir, what is mass spectra? What it means? What do you mean by mass spectra? See, this tells you two things. For us, for AP, this tells you two things. What, sir? Total number. So, do you know what are isotopes? Tell me first. Do you guys know what are isotopes? Isotopes.
Yes, sir.
What are they? Tell me, tell me.
Different mass numbers, same
But the
atomic number.
same atomic number, right?
Yes, sir.
So if your mass spectra is given to you, you can tell them what are the total number of isotopes present for that particular atom. First thing you can get from here. Okay, sir. Second thing which you can get from here is their average atomic weights. Average atomic weights. You might have seen that, sir, Cl has two isotopes, Cl35 as well, Cl37 as well. What is the mass number of Cl we should take in common? In general, we take sir 35.5. So how this is coming and which mass is this? This is called the average atomic mass. And how we can find it out? By checking how much percentage each isotope is present in nature. Is it fine for you? What percentage each isotope is present in nature? If you know that, you can multiply that with this mass number, and for the other also multiply with that mass number and sum them up, you'll get the answer of that average atomic weight. I will give you one question, you will get it. Don't worry. Okay. Let me say that first of all, let us say in the nature we have 35 Cl as 75% and 37 Cl is 25% only. So I want to find out the average atomic weight for Cl. Average atomic weight of Cl. What it will be? So nothing you have to do. No need to worry also. Nothing you have to do. There is just you take the mass number of Cl, the above Cl, and multiply it with the this value 75 plus. Take the other mass number 37, multiply with the percentage which is 25 and divide it by the total percentage whatever you are having, which is 75 plus 25, 100. Do you agree with me? Yeah. I am having
Yes, sir.
75% of that Cl which is having mass number 35 in the nature. I am having 25% of that Cl which is having 37 mass number present in the nature. I am dividing it by the total percentage and I'll be getting the average atomic mass in this manner. Simple, very simple. Is it okay? If you solve it, if you will be getting 35.5 only. And because it's an average atomic weight, the units will be U. I hope it is clear.
Yes, sir.
U or gram per mole, anything you can use. Mrinal, is this fine?
Yes, sir. Fine, sir.
Okay, cool then. If this is clear, then I don't think so you will be getting any problem in the mass spectra. So, sir, how does the mass spectra look like? The mass spectra look like this. A graph will be there, which is representing M by Z ratio. What is M? M is the mass, Z is the charge. And for you guys, for AP syllabus, Z will always be equal to 1. Z will 100% always be equal to 1. Okay? Every time. Z is equal to 1 itself for you guys. But yes, in the x-axis it is a m by z ratio, not only the mass. Okay, and here they can give you the percentage abundance on the y-axis. Okay, fine. Let me say that this is a spectra for boron. Spectra for boron. So it will look like something like this. See, I am writing here 10, I am writing here 11. This is, let's say, 80%, and this is, let's say, 20%. Okay, yeah, let me say that 80 is here. Yes. I want to find out, first of all, how many isotopes of boron exist in nature. Can you tell that from the spectra? If this is a spectra for boron, can you tell that how many isotopes of boron exist here? Tell me quickly. Is it possible for me to tell this? As the number of peaks can give you the value of number of isotopes, isn't it? I
Yes,
am
sir.
having one value at 10, one value at 11. Obviously, sir, then two isotopes of boron must exist here. Do you agree?
Yes, sir.
And then how to find out the average atomic weight for boron? From seeing the graph. Sir, we know that we are having mass number 10, and at mass number 10 is present as 80% in the nature. Do you agree with me? And mass number 11 is there and it is present 20% in nature. So you just do it. I don't think so there is any difficulty here. So to find out the average atomic weight, we just have to do 10 into 80 plus 11 into 20 divided by 100, which is the total percentage. Isn't it?
Yes,
It's
sir.
fine. Okay, cool then. So this is the way to just interpret the mass spectra. I hope it is clear. The interpretation of the mass spectra is clear to you. Okay. Then let us. Achha, what is the value you are getting over here? 10.2 U. You can check it by solving it. 10.2 we will be getting over here. Achha, sir. Is this the only way the mass spectra is given? That is so easy. No, there can be another type of mass spectra also. Just a second. In which they will give you percentage relative abundance. Which in the last case, they gave you percentage abundance, but now they are giving you percentage relative abundance. And the same, it is also the spectra for boron itself. Spectra for boron itself. And similarly, they have mentioned here 10, they have mentioned here 11. And now this value represents up to 100 because it's a relative term. So they said that, okay, this is 100. And with respect to that, this is 25. At 11, we are having a peak at 25%. This is the spectra for boron itself, right? So how will you be able to do that? How will you solve this? See, in the above case, it was percentage abundance. Okay, 80% I am having for mass number 10, 20% I am having for mass number 11. Now they are saying percentage relative abundance. Relative means, sir, you take one as 100%, and with respect to that 100%, take the next one. Think about the next one. How much percentage is my next mass number boron present? Next isotope present. So see, the ratio will remain same, isn't it? So it is 80 is to 20 ratio, which is 4 is to 1. So here also, if you see percentage relative abundance, I am taking the maximum, like whatever the isotope which is present in the maximum amount, I am taking it as 100. So okay, 100 is to 25. The ratio remains same, 4 is to 1. Do you agree with me? Yes?
Yes, sir.
Okay. So now, sir, how to find out the average atomic weight from here? It's a similar thing. Average atomic weight is the similar thing. What you can do is, how, like the 10 mass number is having what percentage? 100 plus 11 mass number is having what percentage? 25 divided by the total percentage. What is the total percentage you are having? 100 plus 25. That means, sir, 125. Done. You will be again getting 10.2 as the answer. Is the most easiest way we can do. We can interpret a mass spectrum. Is it clear to you?
Yes, sir.
Both of you, right?
Yes, sir.
Fine. Okay. So they might give you percentage abundance alone. They might can give you percentage relative abundance as well. And they can ask you, can you draw the mass spectra for Cl here? For this case, can we draw the mass spectra of Cl as well? here? Quickly, can we draw it? So nothing you have to do. You have to take m by z value here. You have to take percentage abundance here and draw it. Sir, one mass number is 35. Okay. Another mass number is 37. Okay. 35 one is present in as 75% in nature. Okay. 75% in nature. And your 37 here is present as 25% in nature. Fine. So this is my corresponding to 75%. This is corresponding to a 25%. Done. Is it clear to you? This is how you have drawn. Yourself we have drawn a mass spectra for Cl. Is it okay?
Okay.
So mass spectra questions, like you will be definitely seeing one question of mass spectra as a sure thing. I am assuring you this will be coming in this manner only. Okay. So I'll be giving you some homework. Have you submitted your homework, any of you? I guess no, right?
How to submit our homework? Direct WhatsApp में भेजा देना.
Make a PDF of it and then submit it to me
Okay,
on
sir.
WhatsApp. You can send me personally also. No need to fill the group. You can send me personally as well. Okay.
Okay, sir.
Okay, then what else we have? After this part, I think we are left with the stoichiometry and the concentration. So you can imagine, you can think of that maybe 30% of this unit is completed. 30%, 30 to 25%. Okay.
Okay,
Maybe
sir.
we require
Please
three
share
more
the
classes
notes for
to.
today, no, sir.
Yeah, I will definitely share it. Don't worry. I will share everything. Homework, notes, whatever. Okay. Clear? Today's class was enjoyable. It's not a boring class, right?
Yes, sir.
Yes,
First
sir.
of all. Okay. So I hope you understood the mass spectra, which was my aim to cover it today. Yes.
Yes,
We
sir.
will be getting some difficult questions also after today's class. If you are able to do that, it's 100% fine. If you are not, that is also 100% fine. This is the maximum level I am touching when which AP never touches actually. Okay. But let's do it. Let's do it for our safety that okay, if sometimes they gave us a difficult question, what we will do. Okay. So I will give you everything. You try to do it. It's not very much questions we will be having here again. Less questions only I'll be giving again. Okay. So we'll meet in Monday's class now. Fine.
Yes, sir.
Up till then, bye bye. You can leave.